Hey guys, welcome to Functions Day 2. So we learned about different ways to represent functions. One way is a verbal rule. Okay, the output is 1 less than twice the input. If we wanted to write an equation for that, the output, we're going to think of our inputs and our outputs. Our output would be our y value, and our input would be our x values. Okay, so think about it like that. So if we wanted to say the output is, we'd say y equals 1 less than twice the input. So remember that keyword than means that the minus 1 will come after. So twice is 2 times x minus 1. Okay, so that equation would represent the verbal rule. Okay, all right, we can also show for an output not just y, but we could say f of x is equal to 2x minus 1. All right, so these two would be equivalent. All right, if we had a table, then if we had an input of 1, all we're doing is saying 2 times 1 is minus 1 is our y value. So that would be 2 minus 1, which would be equal to 1. So an input of 1 would give us an output of 1. Okay, an input of 2 times 2 minus 1 would give us 4 minus 1, which is 3. Okay, an input of 3, so y is equal to 2 times 3 minus 1, would give us 6 minus 1, which is 5. And for 4, with this function, we'd have y is equal to 2 times 4 minus 1, which is 8 minus 1, which is 7. Okay, so we just populated the table with the given inputs. Now, these x and y's will then create ordered pairs. So 1 would be the first value. So when we graphed it, it would look like this point here. Then we'd have a 2, 3 would be right here. A 3, 5. We'd go 1, 2, 3, 1, 2, 3, 4, 5, and then a 4, 7. So 4, 1, 2, 3, 4, 5, 6, 7. Okay, so we have the 4 points on the graph. Okay, looking at the graph as it is, the domain, okay, if you recall, we have domain and range, x and y, so the domain is our x values. So if we look at our x values either from the table or the graph, the domain in this state would be 1, 2, 3, and 4. And remember, we list the domain in ascending order, least to greatest, and we don't list any duplicates. All right, and the range would be the y values, which would be 1, 3, 5, and 7. Okay, all right, so that's as the graph is shown right there with the 4 points. Now, if we took the equation and we actually graphed it, in this case it's a line, okay, if we graphed it as a line, we now have an infinite number of points on that line. So we can't possibly list an infinite number of elements in the set for domain, so we actually would represent that the domain as being all real numbers, because it could be anything, any x value. We could have 1,000,000, we could have negative 6 billion, doesn't matter what the x values would be. And the same with the y values. The y values could also be any real number. All right, so if when you take those points and you connect them to a line, it does change the domain and range, and we will talk about that. Okay, so now we have an example. Okay, we're going backwards, and this actually worked better in class, but I'm going to kind of walk you through it. So here we have the points. So from the points, I can then come up with my x and y values. So if I had an input of 6, my output would be 1, because that ordered pair is 6, 1. Okay, we have a 5, 2. So input of 5, output of 2. Then we've got a 4, 3. 4, 3, and then we have a 3, 4. Okay, so there are inputs and outputs. If we want to come up with the verbal rule in the equation, all right, I find the equation would be easier to come up with. So let's look at the pattern here. Okay, in class we kind of went back and forth trying to come up with a pattern. How can you go from 6 to 1, 5 to 2, 4 to 3? Okay, and then somebody said, hey, wait a minute, the x and y add up to 7. Okay, well, if x and y always add up to 7, then let's solve for y. All right, our y, our output, is actually going to be equal to negative 7 minus x, or we can write it as y is equal to negative x plus 7, either way. All right, so I'm going to just leave it as y is equal to 7 minus x, okay? Because then I can write my verbal rule, which would say y is the output. The output is 7 less the input. Now notice I didn't say less than because it's 7 less, meaning start with 7 and then you subtract. Okay? So from here, again, my domain would be my x values, and I'm going to put them in ascending order, so I'm going to list them as 3, 4, 5, and 6. And my range would be 1, 2, 3, and 4. All right, again, if I connected these points and I actually made a line, okay, which we will do in the next unit, I would change the domain to be anything because I have an infinite number of points on that line. Okay, so it would be all real numbers, and the range would also be all real numbers. Okay, all right, so evaluating the functions. Now this says h of x is equal to 3x minus 2. Find h of negative 6. All that really means is let's let x be equal to negative 6. All right, and we just plug it in. 3 times negative 6 minus 2 is negative 18 minus 2, which is negative 20. So you can either circle negative 20 as the answer or write it out and say h of negative 6 is equal to negative 20. Okay, we do that for each one of these examples. So now we've got a function that's g of n. So we're finding g of 8. So that means we're just going to let our n be equal to 8. And we plug it in. Negative 2 times 8 minus 1. We've got a negative 16 minus 1 is negative 17. Okay, so I'm going to just list it like that. Again, I could say g of 8 is equal to negative 17. Either answer is fine. Okay, f of 8, we let, in this case it's f of a, so we're going to let a be equal to 8. And now because it's negative a, it's negative 8 plus 5, that would be equal to negative 3. So there's our answer, or we could say f of 8 is equal to negative 3. All right, and then the last one we have here is g of negative 5. So we're going to let our n be equal to negative 5. And plug it in. Negative 3 times negative 5 plus 3. So we got our 15 plus 3, and we get 18. All right, or we could say g of negative 5 is equal to 18. Okay, so the next topic we're going to talk about is what's called the zero of a function. All right, a zero of a function is the x value for which the function the output equals 0, or y equals 0. Okay, because y equals 0 along the x-axis, okay, right here, the 0 of the function is actually also known as the x-intercept, okay? So it's where it is crossing the x-axis. So in this particular example, I can look at the value and see that the 0 of the function is actually negative 2, 0. Okay, all right, so that would be the 0 of the function. It's also the x-intercept. Okay, we can also, looking at the graph of the function, it's given by the equation f of x is equal to 2x plus 4. Okay, if we want to see where it crosses the x-axis, or the 0 of the function, we take the output and we make it equal to 0. Notice that point right there is the output. So we're setting f of x equal to 0, and then we're just going to solve for x. Okay, so we do it just like we solved all our equations. We've got negative 4 equals 2x. We divide by 2, and our x is equal to a negative 2. Okay, so the 0 of the function, we can either look at the graph and see the point that it crosses, or solve it algebraically and get the point negative 2, 0. All right, so in that case, it's also the x-intercept. Now the y-intercept we're going to talk about later, but the y-intercept would be right here where it crosses the y-axis, and that would be at 0, 1, 2, 3, 4. That would be at 0, 4. Okay. All right, so when we do find the zeros of the function, again, we set the output to be 0, and we solve. All right, so we're just going to use the golden rule of algebra, bring the 1 to the other side. All right, and then we're going to divide both sides by negative 2. So our x is equal to 1/2. All right, so the 0 of the function is 1/2. All right, or we can list it as an ordered pair, okay, where it's 1/2, 0, because our output is always 0. Here we solve. Okay, we bring the 5 to the other side. We divide by negative 1, and our x is equal to 5. All right, or we could say 5, 0. Okay, so that's finding the 0 of the function. All right, now we've got an example with 3 different functions. We have f of x is equal to 3x minus 1, g of x is equal to negative 5x, and h of x is 6 divided by x. We want to find each value. So if we're finding f of 2, see how it starts with the f? That means we're just going to use that f function. And we're going to let x be equal to 2. So we're using f of x is equal to 3x minus 1. So now we're just going to plug it in. 3 times 2 minus 1. 6 minus 1 is 5. So f of 2 is equal to 5. All right. If I wanted to find g of negative 4, I look at my g function, and the g of x is equal to negative 5x. Okay, so we're going to let x be equal to negative 4. And this becomes negative 5 times negative 4 is equal to 20. All right. Number 9, we're looking at f of negative 1, so we go back to the f of x function. So f of x is equal to 3x minus 1. And we let our x be equal to negative 1, and we plug it in. And that's equal to a negative 4. And then g of 0, now we're bouncing back to the g function. And we let x be 0. So negative 5 times 0 is just 0. Okay, now we've got 2 examples using the h function down here. So the h function says h of x is equal to 6 divided by x. Okay, so when we have 6 divided by x, okay, we're going to let, in this case, our x is 2 because the input's 2. So 6 divided by 2 is 3. Okay, and then the last one, h of 0, we're using h of x is equal to 6 divided by x. We let our x be 0. When we plug it in, we get 6 divided by 0. Well, you're going to get an error on the calculator because we can never divide by 0. So that would be undefined. Okay, so I hope this video helped. Bye, guys.